Hi students, this is AJ sir. Let's study 9th standard ICSE Math, chapter 22, exercise B, trigonometrical ratios, advanced. Also, to enroll for my online lectures or online test series, email me or message me on Instagram. Check the description for more information. Now, this exercise has nothing new, but everything is new in this exercise. We can solve each sum with the methods we have studied in the A exercise, or we can start using the various trigonometry formulae to solve them quickly. So I hope you all have studied and you remember all the reciprocal relationships, this table, the three identities, and the complementary angles relationships. These are the various formulae we shall use in this exercise. So please be very thorough with all of this beforehand. Let's start with the second sum. Use the given figure to find the values of sine x, cos y, and this expression, of course. Now, if you look at sine x, we have to consider triangle ABC. That's the right angle triangle. Sine x value cannot be obtained from triangle ACD because that is not a right angle triangle. Sine is opposite upon hypotenuse. That's AB upon AC, that's 8 upon 17. But cos y is adjacent upon hypotenuse, that is BD upon AD. Now we know BD is 6, but we don't know AD. So first we will use Pythagoras theorem in triangle ABD to find AD, which will turn out to be 10. And also we should use Pythagoras theorem to find CB, which will be required in Roman number 3 to find tan x. So that way BC would turn out to be 15. And then you can find all the values: sin x, cos y, tan x, sin y, cos y, and you can substitute them and solve it. So here's the solution. Note here the labeling I have given is A, B, C here and D out here, so be careful about it. Pythagoras theorem twice, sin x, cos y, first find tan x and sin y, then substitute in this expression and solve it algebraically to get the final answer. The final answer has to be in mixed fraction compulsorily. Next, the fourth sum. Mark that as IMP. It's a right angle triangle and we have another perpendicular to the hypotenuse. These values are given 3, 4, so we know by Pythagoras theorem AC will be 5. Now we have to find tan of angle DBC, that is this angle. But in triangle DBC, we only know one value, 3 centimeters. So for tan, I need one more value, which is not possible to obtain in this sum. So what if we prove that DBC angle is equal to angle A? See, this is 90 degrees. Assume this is X. So this angle will become 90 minus X by angle sum property. Now if you take the big triangle ABC, again angle B is 90 totally and this is 90 minus X. So by angle sum property again this will become X. That means indeed this angle is equal to this angle. So when they ask for tan of angle DBC, it is the same as tan of angle CAB. And tan of angle A is easy to obtain because we have all the sides of triangle ABC. Tan of A will be opposite upon adjacent, that is 3 upon 4. So that means tan of DBC is also 3 upon 4. Similarly, for finding sine of angle DBA, that is this angle, we can't use triangle DBA because we have only one side, 4 centimeters. But this angle DBA is actually equal to angle DCB. Yeah, angle C is 90 minus x, and if you do angle sum property in this triangle, even this is 90 minus x. So instead of finding sine of this, we can first find sine of angle C, and sine of angle C is opposite upon hypotenuse, that is 4 upon 5. That means sine of angle this is also 4 upon 5. Here's the solution. First we use Pythagoras theorem to find AC. Then we find all the angles in terms of x. Some will be 90 minus x while some will be x. And then Roman number 1, tan of this angle is nothing but tan of A, which we can find easily. And sine of this angle is nothing but sine of angle C, which we can find easily. Next, the sixth sum. In the figure given below, it's an isosceles triangle. Okay, that means AB is equal to AC, and their values are given. This is 5 and this is 5 and this is 8, and we have to find these trigonometrical ratios and expressions. But we can find trigonometrical ratios only in right angle triangles, and I don't see any 90 degrees here. So what would you do in such a case? Yes, you are right. We will draw perpendicular AD to the base BC. And you know, the perpendicular to the base of an isosceles triangle bisects the base. That means BD becomes 4 and DC becomes 4. The two triangles are congruent. Now, if you look at any one triangle, you can use Pythagoras theorem to find AD, which comes out to be 3. And now you can find all the trigonometrical ratios. For example, sine B, Roman number 1 is sine B, that is opposite upon hypotenuse, opposite upon hypotenuse, that is 3 upon 5. Similarly, tan of C, so focus on this right angle triangle, that would be opposite upon adjacent 3 upon 4. Similarly, you can find cos C, then you can substitute the values in the expression and get the answer. For Roman number 4, find cot B, substitute and get the answer. That's it. Now something interesting here, cos square B plus cos square C plus sine square B. If you notice, B and C are equal angles. It's an isosceles triangle. So this is same thing as sine square B plus cos square B. And there is one identity that sine square theta plus cos square theta is always equal to 1. So we knew before solving that the answer has to be 1. Yes, you can use the identity, but then you'll have to first prove that or state that angle B and C are equal. So even that method is fine. You can use identities in this exercise, even though it actually belongs to a future chapter. Now, question number 8 is IMP. Using these measurements given in the figure, find the following values. So, this is the figure. First, they've asked us to find sine of phi. The symbol is phi. Sine is opposite upon hypotenuse. So, I will have to find DC first, which we can find by Pythagoras theorem. So, that will be 5 upon 13. That is the answer. They also want tan theta. If you look at theta, that should belong to a right angle triangle, but I don't see it belonging to any right angle triangle. So what would you do? That's right, we'll draw a perpendicular DE perpendicular to AB. So construction has to be mentioned always. So that means that DE becomes parallel to BC, and now in quadrilateral EDCB I see 1, 2, 3 right angles. So it's a rectangle now. That means ED is equal to BC 12, opposite sides. And even EB is equal to DC 5, 5 and 5, opposite sides of rectangle. Now if this is 5, how much is AE? 9. 14 minus 5 is 9. So I got this as 9, I got this as 12. This should help us to find all the trigonometrical ratios. So tan theta now, tan theta is opposite upon adjacent. So opposite side is ED and adjacent is EA. So that's 12 upon 9. And after reduction that becomes 4 upon 3. Next, they want an expression for AD in terms of theta. AD in terms of theta. So first of all, give me a ratio where AD is involved. A trigonometrical ratio. AD is a hypotenuse. So we can go for sine, we can go for cos, we can go for sec and for cosec, because all of them will have AD in the ratio. But let's choose something where AD is in the numerator. So let's go for sec theta. So sec theta is equal to hypotenuse upon adjacent. That is AD upon AE. Now AE's value we know. It's 9. So if you cross multiply, we get AD is equal to 9 sec theta. So we now have an expression, that is an equation for AD in terms of theta. Why didn't I use sine or cos? Because then AD would have been in denominator. So I would have got something like 9 upon cos theta. So that is also allowed, but I preferred an equation without any denominator. We could have used cosec theta also, that is also allowed. Next, the 10th sum. If sine A plus cos A is equal to 2, find the value of sine square A plus cos square A. Well, no diagram is required for this because it's not a geometry sum. Till now whatever we've done was geometry. Even the fourth sum, for fourth sum you should draw the diagram, it's necessary always. Even if the diagram is given, we have to draw it. So here we'll do squaring both the sides. Now this becomes a plus b the whole square, that is a squared plus b squared plus 2ab. By the way, in trigonometry we don't write sine a the whole square, we write sine square a. And instead of cosec a the whole square, we write cosec square a. And 2ab. You know, sine a and cosec a are reciprocals of each other. Cosec a is 1 upon sine a. So they get cancelled. So what is remaining is 2, that becomes minus 2, and the final answer is 2. Next, mark the 12th sum as IMP. 5 cos a minus 12 sine a is equal to 0. That is what is given. Oh, that's the 14th sum. 4 sine theta is equal to 3 cos theta. That is what is given. That is a 12th sum. Mark it as IMP. So here we'll send cos down here and 4 down here. So it becomes sine theta upon cos theta is equal to 3 upon 4. And you should now know that sine upon cos is tan theta. Please don't think theta cancelled. Okay, it's trigonometry. That is 3 upon 4. And now they have asked us to find certain things like sine theta, cos theta, etc. How would you solve this? Well, if you remember what we did in A exercises, using this information, we can actually assume a right angle triangle. We can assume this to be theta, let's say ABC triangle. And tan theta is 3 upon 4, that means opposite upon adjacent. So this will be 3x, this will be 4x. So we can use Pythagoras theorem to find this as 5x. And now we can find whatever they want. They want sine theta, cosec theta, cos theta, cot theta. Find all the ratios, substitute here and get the answer. So that is one method. There are some other methods also which I will teach in some future sums, but we shall use this method itself in this sum. So we are assuming all this, so you have to mention it. You have to use Pythagoras theorem, find it, find all the values of the trigonometrical ratios, Remember, in the final answers, x disappears, of course. Cosec theta, you could have used trigonometry, or you could have used the reciprocal to find the value. Substitute it, get the answer. This is interesting. Cot square theta minus cosec square theta is -1. You should already know this answer, because you know there is an identity which says that cosec square a minus cot square a is 1. So if I do cot square a minus cosec square a, it will be -1. That's what we have proved here. Here, of course, there is no direct formula. So you'll substitute the values and we'll get the answer. Please show all the steps. Don't just copy. Do the LCM and find the mixed fraction answer. Next, the 14th sum. Here, 5 cos a minus 12 sin a is equal to 0, and evaluate this. So, first of all, send minus 12 sin a on the other side, becomes 12 sin a. Sin goes down and 5 goes down here, so we get the value of cot a, because cos upon sin is cot a. By the way, you could have sent cos down here and 12 down here. Also, you would have got the value of tan a, but that's the same thing. And now, what do we do ahead? Well, since we have cot a, you would think that we can have a triangle. We can assume this to be 12, and this has 5, and we can use Pythagoras theorem to find the hypotenuse, and then we can find all the remaining trigonometrical ratios that are required, like sin a and cos a. Fine, that is a right method, just like we solved the 12th sum. But now let me show you another method. In the question, they have sin a and cos a in the expression that they want, sin a and cos a, and all we have is cot a. Is there any way we can convert the given question in terms of cot a? What is cot a? It is cos a upon sin a. So how about this? We have this expression. We divide the numerator by sin a and even the denominator by sin a. Effectively, we are not changing much, because sin a could be cancelled and we will get back the original thing. But the beauty of dividing this by sin a is that after we split the numerator terms and the denominator terms, see what happens. Sin a gone, so that is 1. Cos a upon sin a is cot a. Again, in denominator, cos a upon sin a is cot a. 2 remains as it is. And sin a cancelled, so -1. So see, I have converted the question into this format. All I need is cot a's value, which I already have, 12 upon 5. So now substitute the value of cot a. And now this is normal fraction sum, LCM, the denominators get cancelled. So final answer is 17 upon 19. So this is a shorter way to do it, using reciprocal relationships. If you don't want to solve it like this, you may go for the normal method of drawing a triangle as well. But let me tell you, in the future, anyway, you will have to use all the identities and the reciprocal relationships to manipulate the sum and solve ahead. So you might as well try to get the hang of it right now. And now the 18th sum. Again, that's IMP. In a rhombus, the diagonals intersect each other, and the cosine, that is the cos of one angle, is given, and OB's value is also given, and we have to find the lengths of all the sides and the diagonals as well. So first draw the diagram. Here OB's value is given as 8, and the cos of angle OAB is given as 0.6. Now, one important principle we will use in this sum is that diagonals of a rhombus are always perpendicular bisectors of each other. That means angle AOB is 90 degrees, and also diagonal DB is definitely 16 centimeters. So we still have to find AC and of course the sides of the rhombus. So our mission is to find OA, because double of that will be AC, and to find AB, which is the side of the rhombus. When they say cos is 0.6, 0.6 means 6 upon 10, that is 3 upon 5 on further reduction. And cos is always adjacent upon hypotenuse, that is OA upon AB. Yes, AB is a hypotenuse. The side opposite to the right angle is always hypotenuse, and is always the biggest side in a triangle. So I got this ratio. So I can assume OA as 3x and AB as 5x. Yeah, don't say that OA is 3 and AB is 5. That's false. It's always 3x and 5x. And now we can use Pythagoras theorem in triangle OAB. OA 3x, AB 5x, and OB we know the actual value as 8. That's great. So now we can use Pythagoras theorem, get the value of x, substitute and get the actual values of AB and OA. And now the sum is so straightforward. The double of OA will give you the diagonal, and each side is also found. And write the final statement. Next, the 20th sum. By the way, you can cancel the 16th and the 19th sum because they are easy and it's a repeated type of sum. Even the 28th one can be cancelled to reduce your homework. Now the 20th sum. In triangle, AD is a perpendicular and all these values are given and some values are to be found. So first draw the triangle. Nowhere have they mentioned it is an isosceles triangle, so don't assume that. All we know is that BD is 9 centimeters. And sine of angle B is given. So this will be similar to the previous sum. Sine is given, so that means the ratio is 8 upon 10, that is 4 upon 5. Let AD be 4x. Let's assume AB as 5x. This is 4x. So use Pythagoras theorem, 5x squared is equal to 4x squared plus 9 squared. Solve ahead, get the value of x, substitute and get the actual value of AB and AD. That's 2 things done, 2 more things left. Next, they have also mentioned tan C is 1. Tan of C is 1. But tan is equal to AD upon DC, that is opposite upon adjacent. It is equal to 1. Cross multiply, that means AD is equal to DC. AD is equal to DC here. And AD we just found out to be 12 centimeters. That means DC is also 12 centimeters. And now use Pythagoras theorem in triangle ADC to find the value of AC as well, which will be 12 root 2 centimeters. So that's the sum. Next, the 22nd sum. Sin A is equal to cos A. So find the value of this. Now again, there are a few methods to do this. First of all, we can assume we can shift cos A down. So 1 is left here. So sin A upon cos A is 1. That means tan A is 1 because sin A upon cos A is 1. And sin A upon cos A is nothing but tan A. Now a few methods. Number 1, draw a triangle. Tan A is 1. That means you can assume this has 1x and this has 1x and find this by Pythagoras theorem root 2 and then find whatever values you want to find. Tan, sec, sine, cos, etc. That's the normal long cut method. But I'm going to use a different method. The second method is tan A is 1, but tan of what angle is actually equal to 1? Look at the table. Tan of what is 1? Tan of 45 is 1. That means this angle A is 45. So tan square A is easy to find. Tan A is 1 means square of that is also 1. So there is just one substitution here, 1. Sec A is how much? 45. Sec 45 is how much? Sec 45 is root 2. So we can substitute this value. We can say it's root 2 the whole square, that is 2. So 2 into 2 is 4. And solve this and get the answer. But I am going to solve it with the third method using identities. I just want to expose you to all different methods here. Then you can choose whatever you are comfortable with, whatever strikes you. But the bottom line is you have to learn the table. You have to learn all the formulae. So if tan square is equal to 1 and the identity says that sec square A is equal to 1 plus tan square A. Yes, that was the identity here. Remember? Sec square A minus tan square A is equal to 1. You have to remember this by heart. So that way also I could get the value of sec square A is 2. So now this is the given expression. Substitute the value here, substitute the value here, solve and get the answer. That's it. Next, 24.2. So here it's given 2 sin x is equal to root 3 and we have to evaluate. That means we have to calculate this. Roman number 2, mark it as IMP. So again there are a few methods. First of all, send 2 down. So sin x value we got it. Now one method, draw a triangle. One side will be root 3, the other side will be 2. Use Pythagoras theorem, find the third side, find the trigonometrical ratios. It's a very long cut method. Another method is, what value of x is, sine of x is root 3 upon 2. Root 3 upon 2 is sine of 60. Note, this will work only if the angles are 0, 30, 45, 60. If they would have given sine x as root 5 upon 5, then we could not have used the table method. We would have to use either the identities method or the triangle method. But here I'm using the table method. Sine x, by the way, first I have found sine square x value, and by the table method x is 60. So now even cos x is cos 60. Find the value of cos 60 from the table, substitute it and get the answer. What if we have to use the identities method? Fine. We know that sine square x plus cos square x is equal to 1. Sine square x value, we got it. So now we can get the cos square x value, which is 1 upon 4. If you send the square on the other side, becomes square root, that is 1 upon 2. And now what have they asked? 3 cos x minus 4 cos cube x. Cos x value we know, it is half. And cos cube x will be half the whole cube. So now solve this further, and the answer is 1. So that was an IMP sum. I showed you so many different methods, so you can do it by any one method. Now the 25th sum, sin A's value is given, sin B's, cos B's value is given, and we have to find the value of tan A minus tan B upon 1 plus tan A into tan B. How do I get the value of tan A and tan B? We have done such sums in the previous exercise. What you can do is we can make one triangle, and then using the sin A ratio we can find the value of tan A. Make a separate triangle, because we don't know if they belong to the same triangle or not. So to be on the safer side, draw a second triangle, use cos B's ratio to find the value of tan B, and then substitute here and get the final answer. But without drawing triangles also we can solve this sum. Let's use the table method. We know that sine of 60 is actually root 3 upon 2. So A is 60, that means tan A is tan 60, which is root 3. And cos B is root 3 upon 2, that means B has to be 30 degrees. And tan B is tan 30, that is 1 upon root 3. So see, without using the triangle, drawing the triangle, we found the value of tan A and of tan B. So now substitute those values and solve. Remember, in the end, if root 3 is left in the denominator, we have to rationalize the denominator. So this is the final answer. Next, the 27th sum. Even here, you can make a triangle, because sec A is root 2 upon 1. So you can use Pythagoras theorem and all that. But there is an easier method. Sec A is root 2, and sec of which angle is root 2? Come on, check it and tell me. Angle A is how much? Look at the table. It's 45. So once you know that angle A is 45 degrees, then you can find the value of cot A, sin A, tan A, cos A, and then it becomes so easy. Then you just substitute the values in the given expression, and you find the LCM, be careful about the squaring, be careful about the signs, and get the final answer. And finally, the 30th sum. Again, they've given 5 cos theta is equal to 6 sin theta. Fine, rearrange the terms, it becomes cos theta upon sin theta, which is cot theta. You could have got the value of tan theta directly, or I've done just a reciprocal of this to get the value of tan theta. So Roman number 1 done. But in Roman number 2, I need the individual values of sin theta and cos theta. How do I do that? Well, you can draw a triangle now and get the value of sin theta and cos theta, or convert everything into tan theta. Remember, divide the numerator as well as the denominator by cos theta. Because then when you separate the terms, look what happens here. Sin upon cos becomes tan. Cos and cos gets cancelled. Sin and cos becomes tan. Cos and cos gets cancelled. And now only tan theta is left, whose value we know. Substitute the values of tan theta and solve LCM, etc.